Hello, my name is George C. Bradley, and today's presentation is on how to run a one-way repeated measures ANOVA using SPSS. A one-way repeated measures ANOVA is a procedure for testing whether the mean of three or more matrix variables are equal to some population. In matrix variables, we're talking about the level of a ratio or interval. Whatever distinguishes these variables, and sometimes just the time of measure distinguishes them, is known as the within factor. The simplest possible scenario examines a single within subject factor with three levels. Let's take a look at our data set. The name of our data set is cancer.sav, and we have four dependent variables. The first is titled total, and that's the initial test of cancer. And then there's treatment, and within a 2-week period, the second week, we'll have a test and treatment again, and on the 4th week, he or she will be tested and treatment again, and on the 6th week, he or she will be tested, and those are your four dependent variables, and this data set is free online. Let's take a look at our assumptions for repeated measure ANOVA, and the first one is independent observation, and that one is met. And number 2, the test variables following a multivariate normal distribution in the population mean, basically normality tests. I'll have an opportunity to take a look at that in sporacity. That is when we do the actual repeat measures analysis, you'll see that we'll test for that. Let's test for our normality here. We'll go to descriptive statistics, explore. Let's go here and get out of that. Let's go to the 4 dependent variables. Those are there. Let's look at outlier, plot. Take out stem and leaf, go to histogram, normality, plots for tests, and we can make sure we display statistics both and the plots. Go here, we can see we have 33, everything is even. Let's take a look at the first. Now we're not going to use the statistic of skewness and kurtosis, but I'll give you the levels anyway. The range is between -1 and +1. If it's between -1 and +1, then it meets normality with skewness, and kurtosis if it's between -2 and +2. Let's go here to our test though, Shapiro-Wilks, and you can see all of these are significant. And when they're significant, that means that that's not met. But we have over 30, and that's over the normal distribution, so it's pretty robust. But right here, you would probably need to look at some other options. When you're running this, you can run it. We're going to run it even though the normality test was not met. Okay, let's run our repeat measure test. We will go here to general linear model, repeated measures. This is a name, the name. I'm going to give this a new name. You can name it factor. I'm going to name it cancer. And how many levels do we have? We have 4 levels. And we're going to add that. We're going to hit define. Okay, 1, 2, 3. This is in time sequence here. 1st, 2nd, 3rd, 4th. We're going to go there. Take this one out. Let's get that one out now. Try that again. Sneak in there. Now we have it. Let's go to plot. We're going to take that. We're going to plot it. Continue. Don't need a post hoc. Don't want to save anything. Let's look at options. Okay, descriptive. Click a few of these. Let's go to compare effect. I always like to use Bonferroni. It's pretty powerful, and that's going to give you the little paired information to see where the differences are. Okay, continue. Let's click on that. Okay, move here. Now we'll look at our descriptive information. Our descriptive information for the different levels. You can see the standard deviation, and you can see that the ends are equal. We're not going to look at the multivariate test. Sphericity, we're going to look at sphericity, and we can see right here with sphericity that it's below, it is significant, so it's below 0.05. That means this has failed. And when it fails, and with the normality, we're going to look at the greenhouse. When this fails, we'll always look at the greenhouse because this is a little bit robust. If everything goes correctly, then you need to look at sphericity. But when things don't go your way, and especially if this is not met, we will go to greenhouse. So we'll go down, look at greenhouse, go across, and yes, that is significant. That is below 0.05. So what's going on there? That means that there are certain combinations within that 4 that are significant, that are different from each other. So we're going to go down, and we're going to go to pairwise comparison. Okay, pairwise comparison. And this shows that first, the initial and week 2, that there was a significant difference. The initial and week 4 was a significant difference. And initial and week 6 was a significant difference. And the most power there was in the initial and week 4. As you can see, that -4 there. You can go through here and you can see there's a significant difference in all of the with all of the combinations. Now the thing that you have here in the pairwise, you see what's different, but you don't have a t-value. So basically when you're at this point and you don't have a t-value, you're going to write this up, you're going to need a t-value. So you would have to use a paired t-test on these different combinations that you have here to actually get a t-value. And I think the last thing you want to see here is a picture. You want to see a picture. You want to see the initial and how it goes up, even though your treatment. And then after the 6 week, it seems to go down a little bit. Seems to go down a little bit. Are there any questions? If you have any questions, please email me at georgecbradley59@gmail.com. Thank you.